Hi everyone, welcome to the Generative AI Introduction course. In this, we are going to build foundation and unlock the creativity through generative AI models. In the dynamic landscape of technology, artificial intelligence has been a game changer. It's a journey from rudimentary algorithms to sophisticated machine learning models, and that has been nothing sort of revolutionary. Now, a new chapter is unfolding that is about generative AI. We are going to learn about generative AI and large language models as an introduction course for this module. We are going to talk about LLM and other use cases of it in the next module. Similarly, we are going to discuss about types of LLMs, text generation before transformers, transformer paper understanding, transformer architecture, where we are deep diving into the transformer, which is the core architecture of all the large language models that are available today. Generating text with transformer will be a quick hands-on and understanding about these models and how they generate text, and definitely attention mechanism, which is another popular technique that is being used in generative AI. So let's look at the first module where we are going to talk about generative AI and LLMs as an introduction, right? So in this course, we are going to talk about generative AI in a little bit more detail while we understand about large language models in much more sophisticated way. So in the inception of AI, back to mid 20th century, with pioneers envisioning machines that could mimic human intelligence, we are now in a position where we are asking these machines to generate new content for us. What does that mean? New content, when we are talking about machine learning models, we had bunch of labeled data set, right? That says it is cat or it's a dog or it's a animal, right? And based on that, it can say, if you feed in a new image of a cat, it can say that it is cat or a dog, right? But how about given a data set, it is able to generate a new image of a cat, right? And this generation is the clue behind generative AI. Let's deep dive into that. So what is generative AI? As I said, generative AI refers to artificial intelligence or techniques that create new content rather than just analyzing or classifying existing data. It doesn't really delve deep into the existing data, but it builds an understanding from the existing data and tries to generate new data from that understanding. Generative AI uses deep learning models, often large language models or diffusion models trained on huge data set. Definitely this is important point because you need to have a lot of data to train these models. They learn the pattern and relationship within different data types and the use of this knowledge to create new original content. It includes algorithms that can generate realistic images, it can generate a piece of art, it can generate code, it can generate compelling text, music, videos, designs, and so on, right? So a lot of use cases that are available in generative AI, which we are going to talk about later sections. But for this, I think it gives you an understanding about generative nature of generative AI. So why generative AI is so popular now? We could have done this before as well. There are three main pillars to the success of generative AI. The first is model sophisticated. Sophistication is more like, there were a lot of algorithms like RNN, LSTM could not have been used before when we were talking about machine learning models. These are all deep learning models, and they definitely improvise the way we capture state. State in the sense, if you have a sentence and we are talking about time here. So if you talk something here and something here. We're talking about each of these are corresponding in state. We're going to talk about these in detail later sections, but this is definitely, I can say, model sophisticated, which is sophistication which actually improvise the way the model works. And one more area, that is data growth. Lot of mobile devices, smartphones that are being used and generating lots of data, IoT devices that are in place, cameras, videos, different machines that are definitely contributing to growth of data, which eventually fuels the innovation for generative AI. And the third section, that is ML industrialization, where we are talking about a lot of robotic sources and a lot of robotic devices, lot of devices that are placed in the fields, machine learning algorithms that are in place and working in the industry, definitely give a lot of boost in understanding the AI and the systems of AI. Moving on, let's understand LLMs, large language models, and what exactly it is and how it works. In a single word, I would say, or we can say, that large language models are nothing but a next word prediction model. Right, before we understand large language models, let's understand what is a model. So, based on historical data and insights, the model acquires knowledge of patterns and behaviors, aiming to replicate these patterns when presented with a new data. A model is LLM, maybe it can be a language model, not necessarily always large language model, essentially a massive mathematical representation of language patterns. So it's trained on vast amounts of text data to learn how words and sentences fit together in a meaningful way. All right, so in a traditional programming, we have a data and we have program and you have a computing logic, and that gives you an output. In machine learning, you have a data and output that basically learns by this model, and that gives you the output. That basically can be a new program as well. Okay, so coming back to model to large language model, and basically before large language model, let's understand language model. Language models are statistical tools that predict the probability of a word or a sequence of words occurring naturally in a language. So that means when I say where are we, where are we, what is the next word? As a human, we know, we can say that where are we going, isn't it? Where are we going? So they are trained on huge amounts of text, learning the pattern and rules of how humans communicate. So it's like, you're teaching a kid, giving a lots of examples how this sentence can be used and what would be the next word. The kid is going to learn it, and it can say that where are we going to happen with going, or maybe where are we, maybe where are we showing, something like that. I mean, just whatever is coming. So any word that can be trained with this sequence of words can be learned as a pattern. Remember, this is a lots of patterns that are given to the language model, the LM, and it is learning from it, right? So the patterns and rules of how humans communicate, language models are essentially learning from that, and it understands that task. So, for example, text generation, which is writing stories and poems where language model can be used, machine translation for converting between languages, we can use language model, speech recognition, understanding spoken words, spelling, grammar correction, all these are some of the applications where language models can be used. Let's understand a little bit more in deeper way that how these language models are working here. It's a game of probability. I would say P of X given Y. So you can see that P of W1, W2, Wn. So P of W1 into P of W2 given W1, P of W3 given W1 and W2, and so on, right? So I can actually predict the probability of a word given a lot of words, right? Isn't it? Given a lot of words. So we can say where are we going in the previous context, which is We are trying to predict the next word based on the given context. Where are we? This is the context. Before I again talk about the working principle of a large language model, I would say there is a lot of advancement that happened from 2019 around when GPT-2 got into GPT-3, where OpenAI start taking over, right? And OpenAI released their first commercial model. It has become so popular. So 2019 to journey of the LMs from 2019 to 2024, 2020, 2021, and you can see 2022, and then we have 2023, and here we are at 2024, and there are a lot of models such as Llama 3. Llama 3 got released last week, and such as Gemini. Gemini got released last year around October. Gemini is by Google, and there is one more model that got released is called Mixtral, right? Mixtral, and also from Databricks. This is DBRX. These are in 2024. So if you see the journey, GPT-4 it started in 2020, and then they got Codex, they got ChatGPT 2023, and then they have GPT-4, right? Similarly, they also been publishing WebGPT, InstructGPT, Bloomberg GPT, and so on. And there is a other set of models that are by Google, like Google T5. Then we have Microsoft MTNLG, and then Google SARD, Google FLAN, UL2, Palm, Flantify, Palm, Flan, and Google Bard, right? So different brands, they have their own set of models. Similarly, AI21 released Jurassica 1, which is also becoming a very popular model. Then there is a Claude today that is available by Anthropic Claude. Uh, we are going to talk about these models in detail in later sections. This is just to give you a timeline of the existing large language models having a size larger than 10 billion. And in the recent years, they are going to cross more amount of data. We are also going to talk about this. What do we mean by billion parameters? Large language models. What is exactly large? We are going to talk about that. So, earlier we had language models, and then we deep dive into that, and maybe we have trained with lot more data than the language models, lot more data than the language models, and it has become large language model. Although it is a relative term, but this large language model terminology is kind of becoming as in every week, every month there is a new model coming in. So models trained on large amounts of all types of publicly available data that can perform wide variety of tasks, including text, image, document summarization, classification, and categorization. And these models can also perform generative tasks like text, image, document generation. And so there is some overlap between LLMs and the generative AI. So what is large in large language models? In terms of large refers to the size of the model in terms of its parameters and the volumes of training data. Parameters are part of the model that learns from historical training data. They also help in predicting the next word in a sequence. And 1 trillion parameters were used in GPT-4. Can you imagine 1 trillion? 1 trillion words or tokens, whatever you say, those are actually called parameters. So GPT 3.5 is too tiniest in comparison to GPT 4. That tiny it is, because it's basically 1 trillion parameters. That's where GPT 4 is being trained on. So this is where the large came in the language models, and that's why they named that as large language models. And then what is language in large language model? So human understandable language like English, French, Spanish, you can say those are the language part. The models learn statistical patterns of the data, example probability of the preceding the noun cat are very high. So there is a next word prediction model, as I said, and it learns from those patterns and a lot of things that are happening given a word and what is to be predicted. And these models can generate new text mimicking humans. The applications of these language models are like text generation, summarization, text completion, translation, sentiment analysis, and so on. The last part, the last word in large language model is the model word, right? So model refers to the mathematical representation of the real world process. Neural networks, the basics of neural network, where I have an input layer, I have a hidden layer, and I have an output layer. The input layer that takes a lot of input as in vector, you can say that inputs are converted into an embedding vector that gets into the process of hidden layers, and then finally it is able to do some kind of task, let's say classification or regression. So a model refers to a mathematical representation of real world process. It is essentially a program or an algorithm trained on data set to recognize patterns, and it uses these patterns to make predictions or decisions without being explicitly programmed to perform tasks. ChatGPT uses GPT-3 or GPT-4 models. There are different models, as we discussed earlier, like Gemini, large language models like Llama 2, Llama 3. All of these are models that is part of the large language model terminology. So, in summary, we can talk about the foundation models, GPT-4 or BART, which are basically, I would say, the language models, the large language models, and these language models are trained on massive data set to achieve advanced language capabilities, language processing capabilities based on deep learning neural network. The foundation models, which is large ML model trained on vast amount of data to fine tune for more specific language understanding and generation of tasks. So these models are basically powerful in terms of what data that they have been trained on, right? And that's what it gives these models a huge capability of generating new set of data. If it has been trained with, let's say, Reddit data, it is definitely been more generic in nature in terms of Reddit specific data generation, but it won't be generic for any other kind of data. So generally they are trying to train with lots of data and different understanding of data from different domains. So the models are becoming more and more generic towards all the domains rather than being specific to a specific domain. But if it is required to have these models to be very specific for a particular domain, we need to feed that set of data so that the model learns from those patterns and able to recognize the patterns in that specific domain. With that, we are able to conclude the understanding of generative AI and large language models. So let's look forward to the next session. Thank you so much, everyone.